Bicycle wheel is the wonderful invention. So when we apply some load here W, and this W will reach to this up through this frame, and when we start pedaling like this through the chain, there will be one torque also generated in this hub. So the combined vertical load W and the torque T transferred through these spokes and this circular rim outer ring to the ground. So how this is works? Why this bicycle wheel is called as a wonderful invention, that we will see also. Through this we will understand the concept the civil engineering like arch, buckling and prestress through the bicycle wheel. So these are the components of the bicycle wheel. This is called spokes, and this is the outer circular part is the rim, and the central cylindrical part is called hub, and these spokes is connected between the outer circular part, this rim and the circular hub, and this is called nipples, which is used to connect these spokes with this rim at this particular point. Through these nipples, adjusting these nipples, we can adjust the tension in these spokes. If you see closely this the structural arrangement of this wheel, each spokes behave like a column. If you consider these spokes alone, this is a column, and these ends are like pinned end conditions. And if we see this outer rim, it is like pure circle in a shape. So this we can assume it as a circular arch. So as we discussed, the force two type of forces applied in this hub. One is downward load W, another one is torque due to pedaling. So how these loads transferred to this ground through these spokes and the rim. So when the load W is applied at this part of the wheel, this W will not be distributed uniformly to all the spokes. Basically, this W is concentrated basically 2 to 3 number of spokes which is located in this zone where very near to the ground. So when it start rotating, this loading unloading will happen. So this high stress will come one by one in all the spokes once it start rotating. So when this due to this load W, this part of the spokes will get some tension and this part of the force will get some compression. Since these all spokes are not like unstressed, it all are pre-stressed column. Basically, when we use the nipples here, so they will tight uniformly all the spokes. So these all spokes already it will be in high tension. So when we apply some load here, this load will not going to create any compression in these spokes. Instead of that, what it will do, already these all spokes will be in some high tension. So it will try to reduce the tension in the spokes. Finally, if you see, say example, in this spokes is subject to all the spokes subject to some 100 kg tension. Due to this load W, these spokes will be subject to let's say some 20 kg means. So from 100 become 80 kg tension only. So the basically it is working in the principle of pre-stress, which means it is coming from the high tension to low tension. It is not going to any compression. If it goes to compression, if you see this cross section, these all are very smaller in diameter. As we mentioned already, these all are two end pinned column. So if you compare to length to cross section, these all are slender column. Definitely it will fail by buckling in the instability criteria. So how this successfully transferring the force means it's all because of the pre-tension applied in these spokes. So the next is the outer part rim. It is the circular arch. If you see this arch bridge and all, this shape will be in parabola. Why it is in parabola? If you see here in the arch, there is no reinforcement at all. It's all our stone arch bridge actually. So if there is a tension, definitely it will collapse because it will not take a high tension at all. Maybe the minor tension it can take, but it will not take any high tension. Since if you closely watch this, these loadings are in the gravity direction. So all are in vertical direction. So we might have studied in our theory part like a parabolic arch which is subjected to uniformly distributed, more or less uniform. This because the major load is here the self weight, live load will be very minor. So this more or less uniformly distributed load. So when parabolic arch subjected to uniformly distributed load will create pure thrust or maybe very minor tension only it will going to create. That is why it is standing without any tension reinforcement. So it is carrying the load for even more than 100 years. It will be safe. There is no crack at all. So the reason is when we apply some vertical load like this, if we don't have this parabola shape arch, if I have some straight beam kind of thing, it will have some bending moment diagram like this. Let's call it as a positive bending moment diagram. So due to this shape of arch in this point, supporting point, we will have one vertical reaction as well as one horizontal reaction at both the end. So due to this horizontal reaction, it will create a one counteracting bending moment diagram something like this. Let's say this is a negative, not positive. This is negative bending moment diagram. So if you see this both a diagram, more or less it will be equal. So if I superimpose this diagram, it will almost match with this, or maybe it will follow the path something like this. So there will be minor tension or even when because there is a small difference in vertical load, so because of that there will be minor tension will be there, but that tension can be taken care by this arch itself, the stones itself. It will not create any cracks at all. That is why that is how this is behaving. So when parabolic arch subjected to uniformly distributed load, it will have pure thrust along the arch. It will reach to the support. It will not create any tension at the structure at all. Same way, if you see in this bicycle wheel, our spokes are arranged in the radial direction. It is not the pure gravity direction. So our loadings are coming this way. So radial direction to the outer rim. If you see all the loadings are pointing towards the center of the wheel. So if we have loading like this, yeah, when a circular arch subjected to radial uniformly distributed radial load line something like this, it will have pure thrust in this arch portion. It will not have any tension or any bending at all here. So that is how it's work. That is why it is called a wonderful invention. So whatever the load we are applying here, this load will be transferred to the ground through these spokes by tension. Even though it will going to create a compression since all our spokes are in pre-tension, this tension is getting reduced. It's not going to reach a zero or any compression at all. Also, all this outer circular portion which is located in the circumference called a rim. This in circular in shape, loads are in radial direction. This part of the spokes going to have more or less uniform. This will have pure compression only, so it can transfer the load to the ground without any tension or any flexure. Same way, we are applying one torque also here. So how this torque is transferred to pure tension to these spokes without any bending, that we will see. So if we closely see the hub here, if you see when I applied some torque here, these spokes are not connected concentrically to the hub if like this. These all spokes, if you see, it is at the outer surface, it is connected tangential to the hub. The reason is when you are having some stone here and the stone is tied with one thread and you are holding here, when you are rotating, it will follow a circular path like this. When you are releasing this stone at some point, maybe at this point, it will not follow the circular path, it will follow something like this. When we from the point of release, it will take the tangential path. Same way, when these all these spokes are connected tangential to the hub, when we are applying some torque, this torque will be transferred to like this, pure tension to the each spokes. If you see, this will be pure tension, here also pure tension like this. When you are moving forward, backward also, alternate spokes will be connected in opposite direction. So that will take care of the tension. So that is the reason these all spokes are connected are tangential to this hub. It's not concentric to this hub. So in another video, we will see the same thing with some commercial software. We will do some analysis. We will see with the number so that we will understand it better way.